Okay, so this one is a little bit messier, and it introduces, again, that initial value problem vocabulary. Really, all that's saying is that the condition that we're given is an initial condition. So if we want to show that y equals sine x cosine x minus cosine x is a solution to the problem, we actually do have to check two things. One, does it satisfy the equation? And two, does it satisfy the initial condition? So let's see. To do this, we're going to need to know what y prime is. So this is going to need a product rule. Derivative. Okay, so we're going to need cosine times the derivative of sine, which is also cosine, so we get cosine squared. And then we're going to need sine times the derivative of cosine, so we will get a sine squared, but it's going to be minus, unfortunately. Otherwise, we'd have that Pythagorean identity, sine squared plus cosine squared equals 1. I would be so happy. And then minus cosine, so the derivative of cosine is minus sine. Okay, so that is our derivative. So this is going to get a little messy, but let's see if we can wade through it. I see cosine squared, so replacing y prime with what I just found, cosine squared x minus sine squared x plus sine x plus tangent x times that original function, sine x cosine x minus cosine x. And I want to know, does that equal cosine squared of x? So this is like a trig identity problem coming back to haunt you. I would say that I'd probably like to start by distributing this tangent x through, and I would love it if we remembered that tangent is sine over cosine. So out here we'll still have cosine squared x minus sine squared x plus sine x, but as we distribute sine x times cosine x, when we multiply that, the cosines are going to cancel out, and we'll be left with sine squared x. Ooh, and I like that. We can cancel those out. And then when we distribute through to the second one, the cosines will cancel again, and we'll just be left with minus sine x, which I also like because that crosses out. And it turns out that it is, in fact, true that that checks out. So the only other thing to check is that y of 0 is negative 1. So we're going to have sine 0 times cosine 0 minus cosine 0. So remember, we're talking about being right over here on the unit circle. Sine, y-coordinate is 0. Cosine is 1. So this whole thing is going to be 0, of course, but then we do get y of 0 equals negative 1. So check, it is a solution. Thanks for watching.